Hello, a very good evening, all of you. Welcome back. So today what we're going to do is we're going to start a new chapter that's continuation of matrices only from the same unit, determinants. So I believe you're all ready, eager for the next topic. You can note down this as we always do. We will start always with the proper definition of any topic that we begin. So you can just note this down. We will soon begin. Shipin line na sana Priyanshu Satyala inti sana Petekrena Nimongla Bandang Shipong Lime Sotila Jongpong San Inti Diha Inti Ala Tako Jongla Bandala Sabongla. Okay, super music. Okay, Kinikali Imsunongla Imsusinla Timongla. Attention, I guess. Achet Pongan Ati Lance Temseminla Lanuina. A very good evening, all of you. Those who have all joined at the right time, being punctual. That's really nice to see. A very good evening, all of you. We'll very shortly begin. So I hope and I'm sure that your pen, paper, everything is ready with you. Ready to start with a new topic. Yes, if possible, do give me a like also, just to just for motivation, because that is also sometimes motivation is very important. Kilang, alam nong la, lanuin la, yeah, all of you, a very good evening. Sangeeta, good evening. Okay, so this is not going to be a very lengthy class today. Today we're just going to get be there with the introduction only, introduction and the topic only, okay, of determinants only. Next session only we will be doing properties of determinants. That is also going to be very important. So today just a brief session, not too many topics today. And yeah, we will be purely focusing on determinants and how to calculate determinants. Alright, so I guess you're ready? Yes, chalo, let's begin. If you haven't liked the video, please give me a like also, as I said, at least for motivation. Chalo, ek like to banta hai. Okay, anyway, I'm just kidding. Let's continue. So, yeah, we had a brief discussion about this topic, if you remember in that last session when we were doing elementary row transformations. Elementary row transformations, that time we had a brief discussion about this, remember. So we're going to do this properly now. So what is a determinant? To be honest, definition is, I believe, written. To be honest, like determinant is actually, good evening, Ronson. It's nothing, okay, it's just a value, as I say, those who were there in that previous class also, you will remember, determinant is actually nothing but just a value that is associated to a matrix. A matrix doesn't have a value, okay. Matrix is just an arrangement of numbers or elements in terms of arrays, in terms of rows and columns. That's what matrix is. Determinant, on the other hand, is like a value that is associated with a matrix. So it's something like the magnitude of the matrix, where the matrix is the vector quantity, the magnitude of that vector quantity is the determinant of that matrix. Something like that, not exactly, not technically I mean, but a way to understand, okay, what is a determinant? A value associated with a matrix, but yes, it will have its own different properties, it will have its own ways of being solved. It can be solved, all right? So, but remember that's some note, you can note it down also, all this stuff that I say, like, determinant can be calculated square matrix. I hope you have written it down. Determinant can be calculated only for a square matrix. If it is not a square matrix, then its determinant will not exist. It's not there. It's not possible. Okay, so determinant is possible only for a square matrix. All right. All right then. So I'll tell you how to calculate the determinants and all. But in the meantime, I guess you have already written this down. So to every square matrix A, that's of Aij, of order n square matrix, a unique number that can be unique. Every matrix will have its own unique determinant. Every determinant will be like unique. Like it's not that for the same matrix I'll get one determinant, you will also get one determinant. No, that cannot happen. It will have its own unique value, just like that inverse. So associated, which is called determinant of the square matrix. So generally square matrix, any matrix, we write it in terms of like this box bracket or that cursive, that round bracket and all. Now, when you go for determinant, this is a notation that we use, that is determinant slash. It should not be read as modulus. Okay, it's not like modulus of A. No, this is determinant of A, where A is what? Not just any number, it's a matrix. So we will be reading it as determinant of A. Sometimes in short we also write it as determinant, DET, determinant of A also. In short, we used to write like that also. Determinant of A will be this value. How to calculate that I'll tell you. We already have a brief discussion on that. So, but what I mean is, please listen carefully. What I mean is, well, this is one mistake which most students do. Okay, this is one place where most students make the mistake. That is, matrix, you'll be using this square box bracket or that round bracket. When you write determinant, you have to be very specific. Determinant in this slash bracket, so the straight line bracket. So if you just happen to write determinant like this, then it's no longer determinant, then your value technically will be absolutely wrong. So you have to be very careful with that. It's like if you're calculating the determinant and then you write box bracket like this, then it's wrong. It has to be this straight line. This is determinant. Alright, so that's exactly what determinant is all about. Now, how do we calculate the determinant of order? Let's say, how do we calculate the determinant? Now, let's see how we calculate the determinant of matrices of different orders. Alright, Shubhamullah, good evening. Let's see how we calculate the determinant of different orders of matrices. So determinant of matrix of order 1. Of order 1. So of order 1, the matrix will have just one element, isn't it? 1 by 1. So if a matrix is of order 1, then it will have only one element that will be of order 1 by 1. Then its determinant of A will be the value itself, because it has only one element. So it's going to be its value itself. Determinant of matrix A of order 1 by 1 will be itself only. Alright, there is nothing much there. Alright, what of order 2 by 2? So the matrix is of order 2 by 2. A11, 12, 21, 22. Remember last class we had a brief discussion on this. So its determinant would be just the cross product of the values, that is A11 into A22 minus A21 into A12. Alright, so with that one example, let's say one example that is 5, 3, 1, 2. This is a matrix A. So what will be its determinant? Its determinant is going to be this bracket, 5, 3, 1, 2. Got that? Alright, can you just kindly calculate this determinant and let me know how much will be this value? Again, write down you can give me your answers in the chat box there. Let me know how much you calculate, what is the value there. Quickly, let's see. Kindly calculate, let me know what are the values quickly. Come on, let's be quick. It's a very simple question. What will be the determinant of this value? You can use this formula, cross multiplication minus Okay, MT has given some, yeah, some of you have given, MT has given 7, 7, chalo, come on, many more, no, 7, national 7, come on, there are more than 30, 40 of you, super music, okay, 7, it's good to see all of you participating, 7, 7, yeah, well, yes, I guess most of you are getting it correctly, so it's good to see that, yeah, that's so nice, wow, the answer just keeps on pouring in, that's really great. That's really motivating and encouraging also. So thank you so much there. So it's 5 into 2, 10 minus 3, that's 7. So that's really nice of you to cooperate. It's really motivating. Yeah, all of you are giving me the correct answers. So, alright, so 2 by 2 matrix determinant value will not be a problem, I guess. See, this value, this determinant, it's like very simple, but Johnson also given 7. Yeah, all of you have given value 7, so that's really nice. This determinant, this is a very simple topic, okay, but what happens is this will be directly a 6-mark question. Maybe after 4 or 5 sessions, we are going to that topic also, where we find out, remember last session I told you there is a way to find out the inverse of a matrix also using another method, determinant method. So there what happens is this plays a very big part. This plays, yeah, 7, that's correct. This plays a very big part, okay, determinant. So especially a 3 by 3 matrix. So we take it very lightly, that's where we make the mistakes, and then, that's why, if you remember, small things and the easy things are the ones which really gives us the headache. So you have to be very careful with. So what of order 3 by 3? How do we calculate? You can quickly prepare your matrix. At this rate, I don't think it will really matter those who are attending classes regularly. At this rate, I don't think it will really matter for you whether it's a lockdown or no lockdown, because most of you are very regular in the classes here. So I guess even if there is a lockdown, as long as network connectivity is good, I'm very sure that you will be carrying on with your studies. So keep it up. It's really motivating for me also. Alright, so the teacher's motivation actually mainly and their cooperation. We might be really very motivated, but the students, if they do not cooperate, then that's demotivation again. But this is like really going on, really motivating. So sometimes even we feel lazy, we don't want, but if the students are so eager, then that's what motivates us. We tend to give you more than our own expectations. No? Alright, so a 3 by 3 matrix. A 3 by 3 matrix. How do we calculate this? Now, this expansion can be done along any particular row or along any particular column. Okay, we can expand this any particular row or any particular column. That's completely up to us. There's no hard and fast rule, but we will get to know later on. But what we will do here now is we are not going to confuse ourselves with too many processes, too many observations, too many methods. I'm just going to stick to one. We're just going to expand along this column, row 1, 2, 3. But you can expand along column 1, you can expand along row 2, you can expand along any one of the columns and rows you can expand. Alright, but let's forget about that. Now see, before we really find out the determinant, this is what we will do. Okay, you can just note determinants, I'll just write it in box bracket. 3 by 3 matrix. So this is a trick. Again, today also I'm going to give you another trick on how to calculate the value of the determinant along any row and any column. Listen, easiest and the simplest way. Okay, you are never going to forget. A1, 1, 1, 1. 1 plus 1 is like what? 2. 2 is an even number. So for even numbers, I'll tell you what is the meaning of all this, but let's talk of just even means positive, odd means negative. Okay, let's just talk about that at the moment. So 1 plus 1 even, so that's plus. 1 plus 2, that's 3. 3 is an odd number, so that's going to be minus. 1 plus 3, 4. 4 even, plus. Likewise, 2 plus 1, 3 even, odd. 2 plus 2, 4, that is even. 2, 5, that is minus. 4 minus plus. So if you wish to expand along any row or any column, this concept will be required. Alright, anyway, now let's begin. Determinant of this particular matrix will be, listen to it very carefully. I am trying to expand along row 1. What I'll do is I'll expand along A11. So when we do that, what happens is if I expand along A11, then it's going to be, I will be neglecting, ignoring its row, its column. So this is left. I'll be multiplying it with this determinant. That is A22, A23. With example, it will be a lot easier. A33. Similarly, so next, again this term, no? A12. Now that's what it means. A12 means odd number. This value will be now negative, minus. Minus, again, this row and this column I will be neglecting. So in that case, what is left? This row and this column is neglected. So A21, A23, 31, 33. Its determinant I'll calculate. Okay? And then we'll proceed to the last element, A13, 3 plus 1, 4. So that's going to be positive. I hope you got the meaning now. A13, its determinant. Ignore its row. A21, A22, A31, A32. I hope you know the meaning of this bracket now. When you do matrices, it's going to be determinant. So whatever be the elements, A11 into the determinant of this value, minus A12 into the determinant of this value, plus A13 into the determinant of this value. That's how you calculate the determinant of a 3 by 3 matrix. So that's why this like a 3 by 3 matrix determinant, to calculate this determinant we have to be slightly more careful. It's not like this 1 by 1 or 2 by 3 matrix and all. No, we have to be slightly more careful with this. Careless mistakes, as we see, can happen from anyone, so we have to be cautious. Likewise, if you wish to expand along column 1, column 2, row 1, row 2, you'll be just following these signs only. No? Even if you don't remember this sign, it's alright, because whenever you get even number positive, when you get odd number, you'll continue, you will attach that with a negative value. Alright, so we'll be calculating the determinant of a 3 by 3 matrix. So let's just quickly calculate one example of a 3 by 3 matrix. Let's calculate one like example. Directly, I'll not write on the matrix determinant directly for you. A 3 by 3 matrix, so 3 minus 4, 5, 3 minus 4, 5. Calculate its determinant. 1, 1 minus 2, 1, 1 minus 2, 2, 3, 1. Ready with that? Let's start. I'll expand along again. Row 1. So 3 into, for the beginning part, I'll just write down. Later on, we can mentally calculate also. So ignore its rows and columns. So 1 minus 2, 3, 1. Minus, right, minus this element, minus 4. That's why I have told you to be very careful. Even after telling you, even I also might make a mistake. So that time, don't laugh at me. So ignore its row and column. So what is left? This row and this column. If I ignore 1 minus 2, 2, 1. And lastly, this element into the determinant. Okay, what was this? 1, 1, 3. So that's 5 into 1, 1, 2, 3. Let's calculate this now. Determinant only. Let's calculate. So that's like 3 into 1 ones are 1 minus 3 twos are minus 6. Minus minus plus 4 into 1 ones are 1 minus 2 twos are minus 4. Minus 4. No? plus 5 into 3 ones are 3 minus 2. So this is like 3 into 1 plus 6 plus 4 into 1 plus 4 plus 5 into 1. So this value will be 3 sevens. 3 sevens are 21 plus 5. 4 fives are 20 plus 5. So that's like 20, 40, 46. Got that? Okay, chalo. So this is basically what is a determinant, the first topic, the introduction topic, just the basic topic. Let's go and finish the exercise. A very small exercise is there. Let's finish it up. Let's complete that exercise quickly. Come on. Chalo. Let's open up your books. Question number 1 is evaluate the determinants in exercise 1 and 2. So first question is evaluate this determinant. 2, 4. Let's go do these questions quickly. Let's not waste time in these questions. So I guess that's done. No, simple questions. Alright, let's move on to number 4. Okay, I'll do 4. Some simple questions I'll be skipping. Because 3 and 4 are basically same. But question number 3 is a 2 by 2 matrix. Question number 4 is a 3 by 3. So step by step, let's calculate what are we supposed to prove. 3 times of A, determinant of 3 times of A. So let's find out this matrix first. 3 times of A, 3, 0, 3, 0, 3, 6, 0, 0, 3, 4, 12. So let's find out its determinant then. determinant of the new matrix, that is triple of A. Let's calculate 3 into, I'm going to do it directly now. Okay, I'm going to do it directly now. 3, so 3, 12, 36 minus 6, 0. Minus 0, so forget about that 0, that no value. 3 into, ignore this row and column, so 0, 0, that's again 0. So like 3 into 36, 3, 6 are 18, 1, 3, 2, 7, 9, 108. Determinant of A, 1, 0, 1, 0, 1, 2, 0, 0, 4. Let's calculate its determinant. 1 into, so ignore this row and column, no, 4 ones are 4, minus 0, minus 0, so 0 into anything is going to be 0, so I'm not going to be proceeding with that, plus 1 into, ignore this row and column. It's very simple, ignore the row and column and then get its determinant. So 0, 0, that's also again 0. So that's like 4 only. So I'm supposed to prove that the determinant of 3 into A is 27 of A. So what is 27 of A? Determinant of A. 27 into 4. 4 7 are 28. 2 left. So this is 108. This is also equal to what? Triple of the matrix A. Determinant of the matrix A. Okay? Let's move on to the next question. Done? Okay. That's the advantage, of course, you can watch later also again. That's the advantage of YouTube. Question number 5, that is again just evaluate the determinants only. So let's do one question, not many. Number 2. Okay, let me present to you another notation that we generally use determinants. Okay, because all these notations, if you get to know that when you read different textbooks, it will be comfortable for you. You will not be surprised like how does this notation come, what is this, no? Another notation that we basically use for determinants is delta. It's also used as area of triangle also. We use it as for determinants also, delta also, value of determinant. We use that also. Okay, delta, small triangle, delta. No? Alright, let's calculate. So first 3 into, okay, I'll write one more time. Some of you might be still confused, so I'll write one more time. It seems like I've done this question and all, it looks a bit similar. Did I do this in the example or what? I think number 2, I've done this as an example unknowingly. So let's change the determinant. It's done in the example, I guess. Is it? Can you just kindly check and let me know? I think this question is done as an example for you. Yes, okay, thank you. So we'll move to another question. Why do the same question again and again, right? So, let's do what? 4 then. Number 4. So 2 into the determinant minus 1 into the determinant we get by ignoring its rows and columns. plus minus 2 into the determinant that we get by ignoring its rows and columns. So this one, ignore its rows and columns, we're left with 2 minus 1 minus 5 0. This one, ignoring its rows and columns, 0 minus 1 3 0. Use your pencil, scale, everything, or if possible your legs also, just to cover up so that there is no confusion. Nah? This one, ignore its rows and columns, 0 2 3. Even after that we might still make mistakes. I cannot guarantee that careless mistakes will not happen. So 2 into 2 zeros are 0, minus 5 ones are 5, minus minus plus 5, no problem with that, plus 1 into 0 minus 3 ones are 3, minus 3, minus minus plus, minus 2 into 0 minus 6. So 2 into minus 5 minus 10, plus 1 into 3 3, minus 2 6 are 12, minus into minus plus 12. So 12 plus 3 15, 15 minus 10. हो गया चलो चलो So what are the next questions again? All right, number 6 also, let us just finish it up. Number 6 also, the matrix A is given as you're simply again told to find out the determinant of this matrix. Alright, let's try to upgrade ourselves now without preparing those determinant values and all. So let's try to do it. So 1 into 9 ones are minus 9, minus 4 threes are 12, minus 12, minus minus plus. Let's try to upgrade ourselves by directly trying to do it. Minus 1 into, after saying that if I make a mistake again, don't laugh at me. 1, so 9, I'll be extra careful now. 9 minus 9 minus plus 12. Okay, minus 1 into 2 nines are minus 18. Suck. Minus 18, minus 5 threes are 15, minus minus plus 15. Plus minus 2 into 2 fours are 8, minus 5. So that's 3 minus minus 3 minus 2 into 3. So it's like 3 plus 3 minus 6. Do we get? We get 0. Next, number 7. Find values of x if, careful here now, 2 4 5 1, 2x 4 6x. Find the value of x. Can be very tempting, but have a look at it properly. Some of you your brains must have already responded, but check again. Yes, some of you must be wondering, we have already done this type of question somewhere. Yes, we have done this type of question somewhere. Similar question. Remember, this is a determinant. Last time we did for matrix. So for equal matrices, elements were equal, so that was chalo, chalega. But this time it is not a matrix. That's why I'm telling you to be careful this time. We cannot just compare its corresponding rows and elements. No. So this will be the values only will be equal. So 2 ones are 2 minus 4 5s are 20 is equal to 2x square minus 4 6 are 24. It's very simple, but again, as I say, in simple values do not make mistakes. Okay. Last question of the exercise. I'm going to do number 8. It's a multiple choice question. It says if these two determinants, if the values, two determinants cannot be equal, if the values of the two x is equal to, then x is equal to the options of A, number B, number C, number D. The options are 6, plus minus 6, minus 6, 0. I'm guessing it might be plus minus 6. Anyway, let's see. So again, determinant not matrices. So corresponding elements are not going to be equal. Determinant, careful with that. So let's find out. So x squared minus 36 is equal to 36 minus 36. So that's x squared minus 36 is equal to 0, isn't it? 2, 18, 36, x is 36. So x squared is equal to 36. So x is equal to plus or minus 6. So option number B will be correct. Because here x can be any values. There is no hard in the question. There is no special condition given that x belongs to natural numbers or positive numbers, and also x can be negative or positive real numbers or even imaginary and complex numbers also. That's also possible again. So the correct option will be plus or minus 6. So that's it. That's it for today. That's the end of determinants. So I guess you've understood a little bit, not little bit, I think you understood completely exactly what is a determinant, how to calculate determinants, 2 by 2, 3 by 3 determinants and all. But again, as I say, your practice will matter. Okay, so how much you practice on this mathematics, all that will matter. All right. So tomorrow we're coming back again. Tomorrow we're coming to more important stuffs, properties of determinants. All right. So, all right then. Yes, and I have one more request to make to you, each and every one of you today. Like, please help me reach out more and more to more and more students. Okay, with this particular channel, because there will be many under lockdown. No classes, and then again total lockdown is going to begin. So please help me share, reach out to maximum of the students. I can do that. I know that with your help. So definitely please do that so that I can help as much as possible all the student community. All right. So anyway, have a good evening to each and every one of you, and sleep well, sleep tight. I'll see you very soon. And yes, thank you each and every one of you for tolerating me. All right, so enjoy your evening, each and every one of you. See you. Bye bye. Take care. Stay safe. I'll see you tomorrow.